guys, this video is recorded to show you how to use ExcelSolver to solve the small bus, large bus problems we formulated. So typically we set up the model in spreadsheet, and then we go to solver and define the function, define the features, and let Excel to do the calculation. So the first step in spreadsheet, we're going to build the model. So first we're going to enter decision variables. I just type in decision variables, and we are going to use L to represent number of large buses and small to represent number of small buses. Okay, and the variables we have to keep in specific cells, and later on we always refer back to the cells. So we are going to keep L in B2 and S in B3. Just to be clear, I always highlight these cells contain decision variables. The second step, we're going to build objective function. So just type in objective function, just type in the word. And this problem is a minimization problem. Okay, and we're going to build a function in B5, highlight 5. So we're going to use Excel function in B5. So before you use Excel function, we always type equal sign. Okay, so our function is 800L plus 600S. So 800 multiply L. So whenever we use variables in the model, we always have to refer to the place where you stored this variable. So L is in B2. You can go ahead and move your mouse and select B2, or you type in B2, but don't type in L. Okay, plus 600 multiply S, which is in B3, and then enter or return. And then we're going to build constraints. Okay, so let me just type in all the signs on the right hand side. First is large buses less than equal to 10, and then small buses less than equal to 8, and we only have 9 drivers, so the number of buses we use has to be less than equal to 9. And then we need to transport 400 students, so your seats have to be have to be more than students. So the first constraint is L less than or equal to 10. Again, whenever you refer to the decision variable, you always have to refer to the cell where you store it. So L is in B2, so go ahead and select B2. Second constraint, S less than or equal to 8, choose S, which is in B3. And then it's L plus S less than or equal to 9. So L is in B2 plus S is in B3. The last function will be 50 times L plus 40 times S. Okay, so far this is all we need in spreadsheet. Then you open solver. So in solver, set objective is the cell where you store objective function. In our case, it should be in B5. So $B, $5. Change to minimization. So by changing variable cells is the place you want to tell ExcelSolver where did you store the decision variables. In our case, it's B2 and B3. So $B, $2, colon, $B, $3. And then we add constraints. So we can first add the first 3 because they all have the same sign, less than equal to. So the left hand side will be from A8 to A10. So $A, $8, colon, $A, $10, and just save some time. I just copy it to the right hand side, and right hand side should be from C8 to C10. Click OK, and then you add the last one. The last one will be A11, greater than or equal to C11. Click OK, and always change this to simplex LP because we're solving linear programming. And then click Solve. Okay, and you click OK. So now you see you get a solution. So the solution tells us we are going to use 4 large buses, 5 small buses, and objective function, which is the total cost, will be $6,200.